Hello, this is Arjan. Today we are gonna go over some of the examples on chapter 2 of the book, and first of all we are gonna construct the models with STAAD Pro, and it's really good that you have the ability to do the hand calculation yourself and compare the results with STAAD Pro results. So first of all, when we launch the STAAD Pro, it's the first page that we see. In order to start our new project, we should come here and select new project. And from there we are going to select the plane because it's a two-dimensional problem. First, the name of the file, let's call it Ch.2 Example.1. Then I'm gonna know what is the directory for this file, so I have to come here and select the file that I'm gonna work with. I have a folder here that is going to be structured as one example, chapter 2. I select that, so all of my files are going to be stored in this area. Then the next important thing is that we have to determine which unit we are going to use. Since it is a US customary units, we are going to go with the feet and kilopound. Then we are going to hit next. Then the first thing that is asking us, do you want to add beam? Yes, sure, finish. So then it launches. Now we have a grid system. The first thing that we have to do, we have to make it in a plan view. In order to do that, there is a cubic here. We are going to select that. It's going to be an XY system. It's good to work with grids so we can deal with changing the grid parameters here in order to fit our problem. But the other solution is that we can adjust and specify the coordinate system for our current problem. So it is our example number 1. We have A, B, C, D. We have total 4 nodes. The first node is 0, 0. The second node is 6, 0. The third node is 15, 0. And the fourth node is 22, 0. So we determine the 4 nodes that we are going to connect. So in order to connect them, so we have to select the white space. Then there is the icon here, add beams. So we are going to select that and connect the nodes together. Then after connecting the nodes, we are going to see that okay, we have the nodes. In order to see the labels, you have one option. You can right click, come to the labels. And if you want to see the node number, you can come here and see node number. So we have node number 1, node number 2, 3, and 4. And node number 1 is equivalent for A to D. So then the next step after we define the geometry is so we are going to go through these tabs. Go to the general. We are going to specify the cross section for these beams. So because we are in this problem, we are going to just examine the axial force, shear force, and bending moment diagram, and we are not going to calculate the deflection. So section property can be any section. So I select all of the beams, come to section database, and I can select one cross section. So I select one W section and assign. So I assign this section to all of my members. So good. The next step is that we have to define the supports. So at node number 1, we have a fixation. So I come here, support. So then we have to create. We have a fixed. The first tab is fixed. So you don't have any movement. You don't have. You have resistance in all directions. You are going to add that. Then the next one is we're gonna have a roller. So it's going to be create. Like select the fixed butt icon, then it's gonna be released in Fx and Fz, Mx, My, Mz, and Fy is gonna be not released. So you have resistance in the Y direction for your roller. And the for hinge, we are gonna assign it to the member. So now we are good to. So then in order to assign it to the node number 1, the fixation, I'm going to select the support tool, use cursor to assign, then assign, then I'm going to select it here. So node number 1 now is fixed. How about the roller, that is the node number D or 4, we are going to assign it to here. So now we see the boundary condition we defined. The only thing that is left is that we have to define the hinge for node number 3. In order to define the hinge, you should know about the trick in STAAD Pro. So in order to do that, you should do the files, command, member specifications, release. So you should remember that in order to define the hinge, you should go to command, member specification, and release. Select release. Then here you have the option. So you have the option start or end of the member you can define. So imagine that we are going to use the end of the member. Then we are going to select which one you want to release. So the hinge is that it's going to release all of the actions except fx and fy. So fx and my have values, but the rest of the parameters are going to be released. So at the end, it means that I have to select the members which the end of that member is node number 3. Then I'm going to add. Then here, very similar. I'm going to use cursor to assign, and do you want to proceed? Yes. I'm going to assign it to the member between node number 2 and 3, because the end of this member is going to be a start of the node number 3. So if I do that, it's like a hinge. So node number 3 is now hinge. Now we defined all of the boundary condition that we have. The next step is that we are gonna put the loads for this system. Then the next step we should go to load and definitions. Then we are gonna go to load case details, add. So because we only have one load case, let's keep it the same. Let's add close. So under this load case, I'm gonna define 2 different loads. Then we have one concentrated moments and one distributed load. The concentrated moment, the value is 5 cubic feet, and it is counterclockwise. So let's first define the concentrated moment. I'm gonna add. So I have a nodal load. Correct. It is mz, and mz should be. So be careful. You have x to the right, y to the top, and z outside of the surface. So the positive moment means counterclockwise. So in the general coordinate system, so mz I should select only 5 cubic feet and add. So I add that. The other load that I have to look for is a member load. It's going to be distributed. So it's going to be gy means global y, the direction. So if in this the direction is global y, it should be negative. So I'm going to select -1 kip per feet. What is the distance of that? It's going to be d1 is 0, d2 is the length of the member, 7 feet, and d3 is also 0 because it doesn't have any eccentricity. Then I'm going to add and close. Then the next step is that we have to assign it to the member that I have. So this is the distributed load with the intensity of 1 cubic feet. I'm going to come here, assign to this member. I have it here. And the next one, I'm going to select this concentrated moment and assign it to node number 2. Now we see. The next step is that you may want to see the values for these loads. So I'm going to come to here, labels. There is load values. So if I click that, I'm going to see that, okay, my loads are shown here, 5 cubic feet and -1,000 pounds per foot. There's an important icon in STAAD Pro that you can adjust the scales for displaying these items. So there's here, so you can come here and change the scale. If I select apply immediately, I can see the effect of change. So bending Z is my moment, so I'm gonna make it smaller. It is the moment diagram, but the point moment that I'm looking for, if I decrease it, it's gonna be bigger. So if I increase it, it's gonna be the smaller. And how about the distributed load? It is fine, but we can change that also. So let's make it a little smaller. Then okay. So I have that. The other important icon is that you can change the display of the units. So there is an icon here, it's called input units, change graphical display units. I'm gonna come here, select, and for the force unit I can change it. So the force is keep, distributed force is pound per foot, but I like it to have keep per foot. So I'm gonna select keeps per foot, and the for moment it is keep feet is fine, then okay. So now it is very similar to my problem. Next step that you should do, so then let's for the final time, let's check all of the members that we have, dimension. If I do that, I see it's fine. So I'm gonna disable dimension. How about, okay. The next step is we have to run the program. In order to run the program, we have to select this tab, analysis and print, and add one analysis option, because even you can specify you want to print it or no. We can just add a general static analysis, then add, then close. Then here, now it is ready to perform the analysis. In order to perform it, let's come here, analyze, run analysis. It's asking, do you want to save? Yes. So now it is saving. All of the time you shouldn't receive any errors and warnings. And then done. We didn't receive anything. Then the next thing is that we should see the post-processing and see the value for the analysis. So I had one load case, and now we see that. The green is the deflection. Deflection was not a point of interest for this problem, but as you can see, you can find out the deflected points for different nodes. If you want to find the reaction, you should select this tab, reaction. Then you can see the reactions, correct? So the reaction for the Y at node number 1 was calculated 3.5 kip, and it is comparable with your hand calculation, and for node number 4 also 3.5 kip. And also you have the moment 47.5 kip feet mz clockwise, and it is correct with the respect to that. So in order to save this data, so it's better to, there is a picture icon in STAAD Pro, so we can take picture. So for instance, let's call it reactions. Okay, so I saved that. The next item that we are looking for is that we are going to see the bending moment diagram. So in order to do that, what should I do? The next step is that we have to define the bending moment diagram. So if you select the beam, you can see the bending moment diagram here. Beam, you select that. Now I can see MZ is active. So now it is the bending moment diagram that I have. But it doesn't have the values. So what should I do in order to see the value? I should click the labels. Then I'm gonna come here and select it. Okay. Results. In order to see the values, you should come to results, view values. Then it's beam results. It is gonna be moment, bending. So bending, I need the ends and the maximum. Shear also ends. Axial displacement and the theta. Okay, close. So now I see the value for bending moment diagram, and we can compare it with the hand calculation that we had for this analysis. In order to save a picture, I'm gonna save it. It's gonna be BMD. Okay, it is saved. The next step is that we are gonna see the shear force diagram. So first, deactivate the MZ, and then let's the shear force Fy. Do you see? We have the shear force. We come up with the 3.5, then go right and draw the shear force diagram. Then you can also compare it with the hand calculation that you have. It is really important to have the understanding, do it yourself, and compare it with analysis and with these finite element packages. Then I'm going to select it. It's going to be shear force diagram, and then okay. The next step is that now we are going to present it. In order to do that, we can come here, File, Export Report, and so first let's make a setup for our report. So let's come here, Printer Report Setup, File, Report Setup. We are going to select what you want to see in the report. You can see the job info, output, the pictures that we took. Let's bring them right, and let's OK. Now the next step is that we have to export this report. So I'm gonna go File, Export Report, or we can print it also. We can select it here and here. Now we saved it in a Microsoft file. Open. So now we saved in an Excel sheet, in a Word file. Then you can maneuver it whatever you want and report it in your analysis. Thank you so much. I'm looking forward to continue this in the next session. Bye.